Alright, imagine we're a long time ago and life isn't around yet. We've got some of the building blocks needed for life just hanging out. What are the next steps in chemical evolution that we would need to turn these little dudes into something actually living? Forming biopolymers. What's a biopolymer? That's when our building blocks team up and link together in long chains. This is what life's molecules are made out of, from DNA and RNA to proteins. Everything needs them to live, so biopolymers are kind of important. In order for chemical evolution to have taken place, nature would need a way to assemble biopolymers. But like hiding your tuna sandwich in a room full of cats, it's a very hard thing to do. Some scientists claim that it was no big deal though. They contend that under the right conditions, making biopolymers is easy enough, and from there, life could flow naturally. But is this really the case? Let's take a look more closely. These building blocks are kind of like fish. They don't have legs. And without something to float around in, they can't get around like they need to in order to do stuff. Because all known life requires water, it is commonly seen as the solution to this problem. Water allows these molecules to bump around and knock into each other, which could help link the monomers into a chain. So, water is needed, but water is actually a big problem as well for two reasons. Like bringing your mom with you on a date, water can slow down or stop chemistry. Water molecules dilute the building blocks, pushing them further apart from one another, making it less likely that they'll be able to interact. Also, water actively breaks down these polymers. Bazillions of water molecules are speeding around and constantly smacking polymer chains around. This frequently breaks the bonds, cutting the chain to pieces, something called hydrolysis. We need a liquid for these building blocks to link up, but the liquid also prevents and destroys the links. That's what makes it a paradox. Some have suggested that wet and dry cycles, or salts, may be able to fix some of these problems. However, wet-dry cycles actually degrade DNA or RNA by removing nucleobases, creating abasic sites. Formation of a biopolymer chain is actually very difficult in wet-dry conditions. Proteins in particular have an additional challenge. Like a balloon animal that relies on air to support its shape, proteins rely on water to support their complex three-dimensional form. When you remove water from a protein, it tends to fall apart, something called denaturation. Many proteins will just irreversibly collapse when dried out. Well, if water is such a problem, what if we just used a different solvent? Geochemists laugh at the idea of large amounts of a different solvent on Earth. We just don't have pools of formamide or methane or whatever lying around. Also, all of the other potential solvents tend to be very volatile as well. They evaporate quickly, or they're only produced in low concentrations, or they're only liquid at temperatures that are incredibly hostile to life, or they're nonpolar, or they're typically produced by biological activity. In other words, there are a lot of problems with using something other than water, and you can't get many of these solvents needed for life unless you already have life. More complex molecules frequently have something called chirality. You can have the same molecule just in different forms, like you have two hands, one left hand and one right hand. All but one of the 20 amino acid building blocks have chirality. Except for glycine, he's pretty silly. The crazy thing about life is that all proteins, all DNA, all RNA, all cell membranes must have the correct chirality or else life would cease to exist. Think of it like molecules having an evil twin. Here is a portion of insulin. According to this paper, if any one of these had the evil twin, the wrong chiral form, it could no longer form the 3D structure properly. If you have a long molecule like DNA, you don't just need the right chirality once. It has to be correct in every one of the 500,000 nucleotides in the simplest free-living form of life. Well, what about these papers? They show ways to preferentially filter or select one chiral form over another. So I guess it's not that big of a deal. Actually, the most successful proof of concept is from this paper, but it's an open secret in the field that the chemistry that's required for this method couldn't have happened on a prebiotic Earth.
A lot of people, our group included, are trying to find more prebiotically relevant reactions that could do what the SOI reaction does. So far, we haven't been able to find one, so that's a kind of a holy grail.
This experiment and others like it are interesting, but basically classified as prebiotically irrelevant. Natural processes are well known to produce equal portions of the two different chiral forms. That's what nature does. Filtering out only one form over another is very unnatural. There's no process that we know of on the prebiotic Earth that could have done this. But it gets worse. It's not as simple as having an evil twin, just left or right-handed chirality. Adenosine, for instance, has 15 evil twins, or 16 chiral forms. It's the identical chemical formula to the other nucleosides. It's still C10H13N5O4, but if you slot one of these evil twins into a creature, bad stuff happens. Fun fact. Platypus venom contains a protein that can flip amino acids of its victims to the wrong chirality, causing devastating pain. You dirty little chirality flipping platypus. Every biopolymer has a chirality problem. So how does modern science deal with it? Well, they largely ignore it. You could read thousands of pages in college-level textbooks or popular works, specifically on biology and the origins of life, and never even come across the concept of chirality. Diagrams that we find in our textbooks may make it seem like there's only one way for things to link up. But linking together different building blocks is hard. The reality is that there are far more ways for these little dudes to link together incorrectly than correctly. Specifically, there's 4 different kinds of ways that it can go wrong. Number 1, intramolecular cyclization. If the bit at the end links to the bit at the front, making a circle, it's lights out for that polymer. He's dead. Number 2. Heterogeneous impurities. Interfering molecules or the wrong molecule could again spell death for a fledgling polymer. 3. Branching malformation. You could have the right thing but have it linking to the wrong spot on another building block. Or number 4, premature truncation. There are monomers that act as terminators. Not that kind of terminator. They prevent further growth. Polymers can go wrong in so many different ways, and the longer one gets, the probability of achieving correct links goes down exponentially. Anyway, with all of the smart people working on this problem for so many years, how's the progress coming? Let's take a trek through science.
Trek through science!
Well, in the 90s, they were able to make a chain, a polymer, that was 11 monomers long. More recent experiments showed that they were able to get a chain up to 50 monomers long. Progress. Unfortunately, more recent papers have shown that these claims were wrong and not reproducible. But regardless of whether they've made a polymer that is this long or this long, even that is with extensive coddling and unnatural cheating. See this video for more information about that. When we remember that the simplest known free-living organism's genome is more than 500,000 nucleotides long, the argument sort of becomes moot. Life is so far in the distance as to be imperceptible. If, by some miracle, a polymer was able to contend with the water paradox, the chirality problem, and linkage issues, it's got a whole lot more to worry about. It has to face deadly heat, UV rays, mechanical wear and tear, ionizing radiation from the Earth, free radicals, and other forces waiting to pounce and break things down. But if you had enough time, though, surely anything could happen, right? Meet Manfred Eigen. He realized that the information in RNA or DNA that's required to maintain life would experience an error catastrophe without complex enzymes that can recognize and fix this damage to DNA. Without these error correction systems, you would essentially die of old age before you were even born. Fortunately for us, all living things are equipped with complex repair mechanisms. Unfortunately for abiogenesis, these mechanisms need to be encoded within DNA. But the DNA can't exist without the repair mechanisms. This is Eigen's paradox, a chicken and egg problem that has been around without a solution for decades. We can't have long strands of DNA or RNA unless it can repair itself. But it can't repair itself unless you have long strands of DNA. Producing any biopolymer through purely natural processes is a huge, frustrating, intractable challenge to science. But life is not based on a few random biopolymers, though. Life requires thousands and thousands of highly specific biopolymers with very precise arrangements of monomers. Even if you could get biopolymers to form by natural processes, keeping them intact is quite another challenge. RNA is so unstable that it needs to be kept in deep freeze, away from sunlight, and it has to be thrown out if it's left at room temperature for more than just a few hours. RNA spoils about as fast as a tall glass of milk on a hot summer day. And we're supposed to believe that molecules like RNA not only existed for millions of years, but also replicated and became more complex. You can believe that if you want, but it'll be in spite of the evidence, and not because of it. Okay, I've got some good news, and some bad news. Bad news is,
Everything is trying to kill you.
those french fries you just ate, probably clogging your arteries right now. Dead. Spiders, they want you dead. The sun wants you dead too. Legos on the floor. Instant death. The good news is, most things are actually sort of bad at killing you. Sun? Bam! Sunscreen. French fries? Bam! Eat some leaves. Legos? Bam! Shoes. Spooters? Also shoes. But, no matter how many shoes you have and leaves you eat, eventually, you will die. We all know that when a living thing dies, nature takes its course. An irreversible one-way path of decay begins. The bits that the thing was made of, its complex molecules, they start to degrade and become disorganized and smelly. This natural process is unavoidable, and we have all observed it. Surprisingly, some really smart people from Charles Darwin to scientists today believe that the opposite process has occurred. They say, a long time ago, purely natural processes somehow created and arranged molecules required for the first ever living organism from a primordial soup, and that led to life as we know it today. Maybe you've seen this contraption before. It's like in every biology textbook. Decades ago, these two scientists, Stanley Miller and Harold Urey, made this experiment to try and test if life can come from non-life, abiogenesis, sometimes called chemical evolution. Textbooks count the Miller-Urey experiment and others like it as evidence of this. The pictures painted that, with a few tweaks and enough time, they're just a hop, jump, and a skip away from creating life. They contend that under the right conditions, getting the building blocks of life is easy enough. And from there, life would flow naturally. But is this really the case? Let's take a look more closely. Simpler chemicals have indeed been transformed into some of the building blocks of life in the lab. That much is true. But how impressive is it? Well, about as impressive as water turning into ice. When the situation is right, water freezes. Pretty cool. Likewise, these building blocks form spontaneously as well when the situation is right. The important questions are, how do these lab experiments compare to reality, and how close do these building blocks get us to life? In other words, if we had the building blocks, will life flow naturally as the biology textbooks seem to indicate? One dirty little secret of these origin of life experiments is that they don't actually start with plausible natural conditions. These experimenters, I don't want to say cheated, let's say they cheated. They sort of just cheated. These scientists begin with pure industrial strength ingredients. These are never found in nature like that in such extreme concentrations and purity, certainly not all in the same location. Billions of dollars worth of precise machinery created and operated by thousands of very intelligent people in labs all around the world over the course of many decades is what gets us to the point where these experiments can even begin. Another dirty little secret of these origin of life experiments lies in the presentation of their results. Even cheating like they did, what exactly do they end up with? The vast majority of what they make is actually toxic garbage. For example, in this paper, over 99% of what they make is not only unwanted, but effectively destroys the building block's ability to form more complex molecules. The very process that makes these building blocks also, critically, stops them dead in their tracks. A little detail your biology textbook may have left out. The third cheat is something called relay synthesis. They buy industrial strength ingredients to start with, make mostly garbage out of it, but may produce trace amounts of something they wanted. Like in this experiment, they yielded 0.011% of the nucleobase adenine. Then they declare success! These chemicals can technically be turned into adenine, even though it is unavailable to actually do anything because it's surrounded by garbage or consumed by side reactions and would quickly degrade, but whatever, details. For the next experiment, rather than starting with what the previous experiment actually produced, this mixture of garbage, instead they now feel justified in purchasing pure adenine from a laboratory supply shop to further cheat at the next step toward life. And this sort of thing happens over and over again, completely detached from reality.
But you admit they are using natural ingredients though, so what's the big deal?
Just to be clear, the experiments are trying to show that these building blocks can form in natural environmental conditions. So yes, these conditions are natural, only in the same sense that your cell phone is also made in natural conditions with natural ingredients. The metal in your cell phone is basically just some melted down rocks. The battery's more simple elements, lithium and cobalt. The glass screen, computer chips, and circuitry, just fancy melted sand. The apps and pictures on your phone, simply arrangements of electrons, another completely natural phenomenon. Every element of your smartphone can be broken down into naturally occurring components, just in concentrations and purities and arrangements never found in nature, very similar to these lab experiments. But you know, I've never seen a cell phone happen in nature, not even one of those old crummy ones you can only play Snake on. How natural things are arranged and their concentrations is key. If I made a cell phone in a lab using ingredients created in factories, am I really simulating a natural process? Or am I using intelligence to direct and create? Now, scientists do acknowledge that starting with these industrial strength chemicals is problematic, but they often express this in coded terms laden with jargon to make it sound less awful. Take this recent paper talking about their use of unnaturally high concentrations of ammonia. They say, this may limit the geographical areas where such chemistries may occur, an aspect that needs further investigation. Translation, nowhere on Earth could they ever expect to find the circumstances they contrived to reach the conclusions they wanted.
Yeah, but given enough time or enough planets in the universe, surely anything could happen. What if we had billions of years?
Some problems are not solvable by time. When people assume that lots of time is abiogenesis's best friend, it seems reasonable. But it's exactly wrong. They're not BFFs. At best, they're frenemies. Yes, time gives more opportunities for things to happen, but what's overlooked is that it also gives more opportunities for time to decay and destroy the trace amounts of biotic material that may have been created. Some of these molecules are very fragile. Their half-lives can span from merely decades, not millennia, all the way down to just days or even minutes. The origin of life is not like a very long journey by foot, where if you could just make a little bit of progress, just one single step, given enough time you could make it any distance. This is a problem of a different category. It's more akin to attempting to walk to the moon. Time won't help that sort of problem. Why not? Well, to give you a rough idea of how large the chasm is, these experiments have produced small molecules like this. And this is just some of what they need for even a very simple, single-celled organism. Thousands of chemical ingredients must be present in the same place, at the same time, the correct concentrations, chirality, with no ability to tolerate anywhere near the level of impurity found in undirected chemical processes or in the lab. Living organisms handle this by making most of the chemicals they need for themselves, on-site and on-demand. But of course that wouldn't be possible before they existed. The chasm between the starting point and the simplest possible life form is so large that abiogenesis is hopelessly and forever off limits to the mechanisms in question. It's not that there isn't enough time, it's nonsensical, like asking how heavy is blue. It's simply the wrong question, and it betrays an ignorance of the scope of the problems involved. In spite of the observable data and our own experience showing us that, left to its own devices, life only goes one way, toward decay and degradation, some still have faith that it could have gone the other way in the distant past with the origin of life. So, When you see statements like,
Life arose via chemical evolution.
that sounds scientific. But that claim is more akin to alchemy or a horoscope than to science. Lots of narrative and hope, but little actual evidence. And so they rely on imagination and people's scientific ignorance to be persuasive. Make sure you're subscribed to get notified when the next video is released. It's going to be a doozy. In the meantime, if you'd like to delve more deeply into questions on the origin of life, check out The Stairway to Life by Drs. Tan and Stadler for a more comprehensive review of the state of origin of life science. Or for a much more technical review, see The Mystery of Life's Origin. Charles Darwin and some modern scientists think that life started all on its own. It sort of just happened spontaneously. It's called chemical evolution. They say it started with chemicals forming building blocks and then combining into polymers like DNA and RNA. These previous videos detailed just some of the scientific problems with that ever happening. Anyway, let's wave our little magic wand and say all those challenges have been solved for now. We don't have life yet, but what are the next steps toward life? Well, just like eggs have a hard time turning into a chicken without a shell, and water balloons are not much fun without the balloon, living things need a cozy little house of their own to keep the good stuff in and the bad stuff out. We're talking cell membranes. All living things are made up of cells that are surrounded by a cell membrane. Life simply cannot exist without membranes. Origin of life researchers claim that cell membranes are easy to make and that they have demonstrated this in the lab. They point toward experiments where these molecules called phospholipids are placed in water and they form into a spherical shell, kind of like a cell membrane, all on their own. Wow. But is it really the case that cell membranes are so easy to form? Let's take a look more closely. Real quick, if you're new here, Long Story Short is about explaining science in an easily digestible way. If that sounds good to you, consider sharing this video with a friend and subscribing for more. Okay, cell membranes, needed for life, supposed to be easy to make. Is that the case? Membranes do a lot of essential things to keep the cell alive. If any are missing, death results. Think of the membrane like a house in outer space. Space house. Nice. Space house provides a safe, comfortable environment inside, despite things outside desperately wanting to kill you. Outside, the temperature can fluctuate between as hot as an oven and as cold as negative 455 degrees. You know, almost as cold as your ex's heart. Not to mention the radiation, lack of oxygen or water, there's a vacuum, space pirates. Inside, though, there's an ample supply of pizza, tacos, warm blankies. That's what I'm talking about. The environment inside the house is controlled and very distinct from the outside. That's what keeps us alive. In a cell, the membrane is responsible for keeping things safe and comfy too. The fancy name for this is homeostasis. But walls that are sealed up tight, with no way to let trash out or new food in, will quickly become a stinky tomb. The cell will quickly die as food runs out and garbage piles up. The very simple membranes that scientists create in the lab are exactly like this. Non-functional, stinky tombs. Real cell membranes need to be tight, but also have very specific doors that actively let things in and out in order to maintain homeostasis. And it needs to have all of this complexity at the very beginning. There's no time for this to gradually evolve because no homeostasis, no life. What if early membranes were a bit leaky, like these papers suggest? Maybe the first cells had holes in them that were just big enough to let good things in and keep the bad stuff out, somehow finding a good balance to maintain homeostasis. Unfortunately, that won't work. All existing cell membranes need to let big things in, while at the same time keeping small things out. In other words, they have conflicting requirements. All cells harness their energy by pumping protons out and very carefully letting them back in to spin these proton turbines, like a hydroelectric power plant. And protons are teensy tiny. To give you a sense of scale, if a proton were the size of a housefly, then a bit that the cell would need to let in, like this amino acid histidine, would be roughly the size of the country of Monaco. And the smallest known cells would be roughly Sweden-sized. Those are the approximate scales that we're working with. Basically, Sweden would need to keep houseflies out, while at the same time letting the Monaco-sized things in. If the membrane let too many fly-sized protons slip in, the cell would die. So the membrane has to be tight enough to not let these teensy-weensy protons in, but also porous enough to be able to let these relatively gigantic things come right on in. These conflicting requirements of the membrane are a real head-scratcher. Fun fact, at any given time, a cell is generating roughly the same voltage per meter across its membrane as a bolt of lightning. Another conflicting requirement is that cells have to let water in, but if water was just allowed to pour in willy-nilly, so would those sneaky tiny little protons, and this would drain the cell's battery, so to speak, and the cell would, again, die. Thankfully, cells have specialized doors called aquaporins. They work sort of like an airlock in our space house by safely letting things in without destroying the nice environment inside. The aquaporin lets water molecules in single file, but that still wouldn't be enough to stop the protons from sneaking in and killing the cell, because the water acts sort of like a wire, conducting the protons along itself. So the aquaporin also rotates each water molecule by 90 degrees, flipping them around and eliminating its ability to conduct protons for just long enough to safely let the water inside. Every cell has tons of these incredibly specialized doors. The simplest known free-living life form is a single-celled guy called Mycoplasma genitalium, but it has thousands of specialized doors composed of over 100 different proteins that operate within the cell membrane. So even the simplest cell has an extraordinarily complex membrane, an active, selectively permeable boundary that allows and often forces exactly the right things in and out to maintain homeostasis. A perfect environment inside the cell, despite wildly varying conditions outside. Leaky membranes and tight membranes would both kill the cell. The membrane had to be extremely complex from the very beginning, or life could never begin. Well, yeah, today it's very complex, but there's been a lot of time for things to evolve. When life was just getting started, there weren't cells, there were proto-cells. They were way simpler. Okay, could life have been simpler? Scientists try to gauge what the simplest possible life form could have been by taking a very simple cell and removing as many things as possible without killing it. These papers took a very simple bacterial cell that had about 985 genes and cut it down to 474 genes. But the bug was barely hanging on, so they added a few genes back in to get a cell that was more reasonably alive. They found 493 genes were essential to keep the minimal cell alive. This work suggests that there is a practical boundary for how simple life can possibly be, not just today, but at any point in time. But in order to cut that many genes from the original 985, they essentially had to coddle the poor, hobbled little bacteria. You see, the original bacteria was able to make its own food from what was around it, like a big boy. But the downsized bacteria needed someone else to make his PB&J for him, and he was picky. He needed it cut into triangles and have the crust cut off. Dad, how many times do I have to tell? It required a precise cocktail of nutrients, basically life support, or else it would die. However, most of these life support nutrients couldn't have existed on a prebiotic Earth. If you try to simplify a living organism, removing some of its tools for survival, it doesn't just magically no longer need that thing. The only way to keep it alive is to place a heavier burden for survival on the surrounding environment. The organism just becomes more genetically fragile, unable to endure slight environmental changes, or it'll become dependent on other life forms to keep it alive, which, if you're paying attention, is not a possibility for the first living thing. Consider yourself. Could you live without legs? Technically, yes. But more requirements will be placed on your environment. You will need a wheelchair, ramps to go up or down, and nice smooth surfaces. Or robot leg. Can you live without kidneys? Technically, yes. But you will need to be hooked up to a sophisticated dialysis machine to do what your kidneys do. 3 times a week for 3 to 5 hours per day for the rest of your life. The more you remove from a person to simplify them, the more requirements are placed on the environment to keep them alive. The same is true for microscopic life. These experiments don't actually do away with needed complexity, it's just exported to the environment. Real cell membranes are complex machines with many required functions, like identifying needed molecules and opening specific doors to let them in or force them in, identifying waste and exporting it, maintaining proper pH, salinity, and osmotic pressure, blocking toxins and dangerous invaders, providing electrical insulation, energy harnessing, and even acting as a template for expanding the membrane during replication, because cells can't actually build a membrane from scratch. They need a pre-existing membrane to do that. The lab-made membranes, on the other hand, do literally none of these things. They're closer to dumb soap bubbles or salad dressing than anything else. When scientific literature or textbooks claim that membranes are easy to create in the lab, it's a lot like saying the Mona Lisa is easy to draw. Or making some dinosaur-shaped chicken nuggets is equivalent to making real actual dinosaurs. There's a bit of a difference there. The observable science makes it clear that, 1, because of the need for homeostasis and the conflicting requirements of cells, the membrane had to be extremely complex right from the very beginning, or life could never have begun. Claims that this problem is even close to being solved are badly misrepresenting the science. And 2, attempting to simplify a living organism merely kicks the can down the road. These experiments only hide the complexity by exporting it to the environment. And a prebiotic environment was certainly not like a lab or hospital ICU. So, when you hear protocell, think leprechaun or rainbow unicorn. There is no evidence that any of these ever existed. And the more science learns about life, the more unscientific chemical evolution becomes. Have started from simply natural processes. Little bit of chemistry here, dash of physics there, a lot of time, and boom, we've got the beginning of life, abiogenesis, right? We've already detailed a number of serious issues with abiogenesis in these videos. But just like your favorite superhero movie, let's briefly ignore the laws of physics. We'll just assume that all of the scientific challenges mentioned in those prior videos have been vaporized. So, we now have lots of building blocks, biopolymers, and a cell membrane that is fully equipped to maintain homeostasis. Awesome. We still wouldn't have life yet, because life is built around something called gradients. A gradient is basically more of something over here and less of it over there. The opposite of a gradient is equilibrium. Physics loves equilibriums, but not so much gradients. For instance, water likes to be in equilibrium, all spread out evenly. But if you build a dam, you can create a gradient, collecting a bunch of water on one side and not a lot of water on the other side. The water naturally wants to flow down from the high side to the low side, and this is where energy can be harnessed. Life does the same thing, except instead of water, cells use proton gradients to capture energy. It's super important. No gradients, no life. To advance further toward life, we would need a continuous supply of these energy gradients and a way to harness them. Some scientists claim that there were plenty of energy sources to support the first proto-life forms. Hydrothermal vents, the sun, lightning, hydrothermal vents, volcanoes, hydrothermal... Is it really the case that life could have started with these kinds of energy sources? Let's take a closer look. It's true, the universe has plenty of raw energy out there, but there's a very important difference between that and what life can actually use to exist. Life is pretty picky. It needs very specific kinds of energy, and it needs to be fed it in a very particular kind of way. Otherwise... It's kind of like trying to charge your cell phone with a charcoal grill. There's lots of energy in the grill, but none of it is usable for your poor, dying phone. To harness the raw energy of the grill into something your phone can use, you would need a set of pretty complex machines. A boiler to heat water into steam, a turbine that the steam pressure can spin, an electric generator, then transformers, converters, regulators to get the energy in just the right form. And then you need the right kind of charger plug thing for your phone, and if you're lucky the cable's long enough so you can lay in bed while it charges, and that's some weird angle. But, like life, your cell phone isn't just picky, it's also fragile. Not only will the grill not charge your cell phone, but it'll also destroy it. If the little circuits and bits in your cell phone get too much energy, or even a little bit of the wrong kind of energy, it's done for. Oh, battery's almost dead. Let's get you some energy. 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 Raw forms of energy can only be used for life if complex machines are available to harness them, and the wrong kind of energy will destroy life. Okay, maybe life didn't get started in a volcano. How about just nearby? Hydrothermal vents are a perfect example. They're a great source of constant energy gradients that early life could have used. Hydrothermal vents aren't like lightning, they're more of a gentle, sustained energy source. Yeah, that is true, but living things can't just absorb energy like a sponge, even if it is gentle. Even the simplest forms of life harness energy through a 3-step process. The fancy term for this process is romantically known as chiasmatic coupling. First, 3 proton-pumping complexes known by their friends as NADH ubiquinone oxyreductase, coenzyme Q cytochrome C oxyreductase, and cytochrome C oxidase. These guys are also known as the respiratory complexes, and together are made of about 25 different proteins, each of which is very fancy in its own regard, consisting of hundreds of precise amino acids. Anyway, these proton complexes use electrons that are stripped off the cell's food source to power machines that pump protons, known as proton pumps, resulting in fewer protons inside the membrane and more protons outside, which conveniently provides an electrical voltage, or a gradient. The respiratory complexes have to be complex because stripping electrons is a dangerous process, like handling a bomb. If any of the 15 reaction steps in this process are mishandled, the loose electrons will destroy the first molecule they encounter. But physics is pretty unhappy about these protons getting kicked out of the cell membrane club and wants to shove them back in. So, step 2. The disgraced protons are only allowed back into the cell if they first turn an electric generator called ATP synthase. In the simplest form of life, ATP synthase is a machine made from at least 20 interconnecting proteins, and it requires other proteins to help assemble it too. Complexity upon complexity. Nick Lane, an Origin of Life researcher and biochemist at University College London, describes ATP synthase as the most impressive nanomachine of them all. It is hard to convey the astonishing complexity of this protein motor. This is precision engineering of the highest order, a magical device, and the more we learn about it, the more marvelous it becomes. Rotation of this ATP synthase motor is used to recharge dead batteries, ADP, turning them into ATP. It doesn't look all that complicated until you realize it looks more like this. And this is slowed down by more than 10-fold. And the cell membrane is so densely packed with these machines, they effectively make the entire surface of the membrane. Step 3. The charged up ATP is plugged into a wide variety of other biological machines to power all the living stuff we need to do, like building proteins, repairing DNA, replication, cell division, blinking, subscribing to this YouTube channel, you name it. When the ATP is discharged and turned into ADP, it gets sent back to the ATP synthase to get charged up again. Fun fact, a typical human generates and uses roughly 1 billion trillion ATP molecules per second. That's your entire body weight in ATP every single day. Whoa. Here's the paradox. The cell needs to make ADP, the empty batteries of life, before they can be charged up to ATP and put to use. But producing one new empty battery requires at least 7 already charged batteries. So you can't make ADP until you already have ATP around in the cell. And ATP is required to build ATP synthase. But ATP synthase is required to charge ADP into ATP. So life's energy harnessing process is one big paradox. You need it before you can have it, and you can't make it until you've already made it. Every part had to arrive, assemble, and start working all at once, leaving no time for it to gradually develop. Hang on a second. Hydrothermal vents are supposed to solve some of these problems, though. There are 2 types of hydrothermal vents. The first are called black smokers, and they do provide raw energy and some very simple molecules that early life would have needed. But on the other hand, black smokers are too hot and too toxic. Any organic compounds that form at these temperatures would quickly degrade back to CO2. They're also very unstable, growing and collapsing over a few decades at most. Not nearly enough time for anything useful to happen, even if it could. They're not seriously seen as a solution to the problem of chemical evolution. The other kind of hydrothermal vents are called white smokers. These are instead proposed to be the solution. They're not as hot, and they're better suited for harnessing energy because of a free pH gradient. And the rock structure provides tiny membrane-like compartments for fledgling life to take root. There are a few big problems with white smokers as well, though. A simple cell requires 100 million times the energy density that could be produced by these alkaline vents. And as you probably guessed, rocks make poor membranes. The rocky membranes in alkaline vents are hundreds of times thicker than the membranes of life. The pH gradient across such a thick membrane would not provide enough useful energy for life. So rather than protecting and nurturing life, these white smokers would strangle it out instead. The high pH also removes the carbon that life needs and is destructive to RNA, and on top of all of that, we would still need complex machines to harness the energy. White smokers do nothing to solve that problem, and scientists are well aware of this difficulty. But life started in a much simpler form. It didn't have to start with something so complex like chemiosmotic coupling. Just look at fermenters or methanogens and acetogens. For harnessing energy in life, fermentation is the only known alternative to chemiosmotic coupling. It produces a small amount of ATP through a simpler process called substrate-level phosphorylation. But this kind of fermentation is not sustainable. You see, strict fermenters pollute their environment, which quickly stops them from growing or reproducing, unless their waste is cleaned up by other forms of life that use chemiosmotic coupling. So this effort to simplify only increases the total complexity. Methanogens and acetogens don't use respiratory complexes to produce their proton gradients, but they still require complex enzymes to produce a proton gradient, and they still rely on the incredibly complex ATP synthase to generate their ATP. So again, this doesn't really simplify the problem. Okay, what if earlier life didn't use ATP? Then it would just need a different set of complex machines to harness whatever other energy it used. Then you would have to explain how those machines transformed into the machines that all of life uses today. In case it needs to be said, there's no evidence for this, but more importantly, it actually makes the problem worse. But we've got lots of time. Time won't help you because you can't store ATP. These things are so unstable, particularly around hydrothermal vents, it'll basically decay instantly. And it's hard to overstate how much ATP is needed every second of every day in order to sustain life. Even if aliens dumped off a big tanker of ATP, it wouldn't help if we didn't have the machines to plug it into, or a way to recharge it. Life requires a continuous supply of energy that must be converted into just the right form by a series of complex molecular machines. And the complex molecular machines themselves could only have been produced by an established energy harnessing process. This is yet another paradox for the origin of life. Imagining that life started simpler and had lots of time to accomplish this is a half-baked idea, like trying to charge your cell phone on a charcoal grill. Defining things is hard, okay? Is a hot dog a sandwich? Is cereal a soup? The world may never know. When it comes to defining life, it's not much easier. But at minimum, we're pretty sure that to get to where we are today, life needed to replicate. Every known cell, including all the cells in your body, came about through replication of a preceding cell. But cellular replication, way too complicated. When scientists talk about how the first forms of life replicated, they have to think simpler. Far simpler. Like at the molecular level. All living things have DNA and have to copy it in order to reproduce. Problem is, copying the DNA molecule is also difficult. Why start there? Let's go even simpler. Scientists figure that RNA is a better candidate for the first replicating molecule. RNA is also found in all of life and is likewise capable of storing the instructions needed to build things, and it's a bit simpler than DNA. So, in 1962, MIT professor Alexander Rich first put forth the RNA world hypothesis, that all of life we see in the world today started from RNA. A few years later, in the late 1960s, this other guy, Saul Spiegelman, demonstrated the powerful ability of RNA to self-replicate, with a lot of help. He tinkered with it for over 75 generations in the lab and produced a molecule that could be replicated 15 times faster than the original. Wow! Fast forwarding a bit, in 1989, these guys, Sidney Altman and Thomas Cech, won the Nobel Prize for demonstrating that RNA can also have enzymatic properties. In other words, RNA can not only store information, we knew that, but it can also turn into simple tools that life needs to do the living stuff. Like a recipe card that can double as a paper airplane, or a frying pan, whatever. RNA could do multiple things. This is amazing. This put more wind in the sails of the RNA world hypothesis. Then, in the 2000s, these papers claimed RNA could self-replicate with just a little bit of help. Again, contradiction in terms, but hey, let's not get too picky, we're only getting started. Even more recently, in these papers, they claimed RNAs evolving right before their very eyes. Everything was coming together for abiogenesis and the RNA world hypothesis. There's almost certainly nothing we're missing in the hype, and there's no serious problems that would bring the whole house of cards down. No siree. Was replication of the first life as easy as they say, or is there more to the story that's being left out? These prior videos reviewed some of the challenges for producing anything close to RNA from natural processes and keeping it from degrading. But for the sake of discussion, we'll just pretend that RNA was easy to make and not a fragile ice sculpture in a Saharan desert that it really is. There are still a large number of challenges in getting RNA to self-replicate. Let's start with Saul Spiegelman, the guy with the RNA that never skipped leg day. The fact that they were able to replicate at all was thanks to them using non-prebiotically relevant conditions. AKA, this proof of concept experiment cheated by stealing an entire working Xerox machine called Q-beta replicase from something that was already living. Well, is it true that they were able to evolve these RNAs to be replicated much more quickly, at least? Technically, yes, but only because the RNAs devolved. After 75 generations of RNA replication, the resulting RNA had lost 83% of the information that they started with. The result was called Spiegelman's monster. A cancerous parasitic RNA that is replicated quickly, doesn't contribute anything useful, and uses up all the resources. This short, useless RNA will outcompete and dominate other useful RNAs, ones that can form useful catalysts or tools, because shorter, simpler molecules will be replicated much faster. Stripped of the hype, all they proved was that a useful strand of RNA, when replicated blindly, favors getting shorter and shorter, spiraling toward uselessness and malignancy. Not the direction you want things to go if you're rooting for chemical evolution. A recent review of this work commented, "Today, Spiegelman's molecules would not be described as self-duplicating." Next up, the Nobel Prize-winning discovery of Sidney Altman and Thomas Cech demonstrated that RNA can indeed act as both the instructions for building molecular tools as well as the tool itself. There was just a bit of fine print, though. It can either do one or the other at any given moment, not both. In order for RNA to be read as instructions or replicated, it has to be unfolded. But in order for it to be useful as a molecular tool, or have a function, it has to fold up into a shape where it can't be replicated. That's a very important thing to note as we continue. Not only that, but RNAs only perform certain functions in life, and by themselves could not run all of the things needed for even very simple life. Sort of like if you're trying to build a house, you could get some work done with just a hammer. But the moment you needed to cut a piece of wood or unscrew something, you'd kind of be out of luck. Especially since RNAs generally don't work as well for tasks that proteins do. RNAs are really good at some things, like a Fisher-Price baby's first tool set. It's great at entertaining a baby. But if you need to actually hammer a nail or saw a piece of wood, those tools are ill-suited for that kind of work. It's not that RNAs are bad at what they do, any more than play tools are bad for playing. You just wouldn't expect the same level of function for things that proteins do. What about the more recent experiments? These papers didn't need the protein enzyme that Spiegelman stole to replicate his RNAs. These guys used clever methods that were completely RNA-based instead. That's pretty cool. The fine print with these papers, though, is that they designed a complex RNA, they cut it in half, and then used a whole one to mush the two halves back together again. So they claim self-replication. It's kind of like buying a car, cutting it in half, and then using another car to push the two halves back together, and claiming, I invented a self-replicating car. These papers took a different route. They did seem to make progress by having a pre-built string of RNA and chopped up complementary pieces combined together, but there's a lot of limitations. The main scientist in most of these papers, Jack Szostak, was a total bro and listed 8 serious challenges with RNA replication in this review paper. Of course, he tries to downplay them, but let's take a look more closely. Number 1, regiospecificity. In other words, when the building blocks link up, they kind of get deformed, grabbing a foot instead of a hand, so to speak. Like a paperweight, super simple RNAs can be a bit wonky and still do a thing, because their thing is pretty simple. If we want a more functional thing, these kinds of deformations would be less tolerated. Number 2, high melting point of long RNAs.
In order to be replicated, a single RNA strand has to have some friends to link up with, to make a complementary strand. And then, importantly, the two strands have to let go of each other. Problem is, the two strands want to link back together again. This is called annealing. And the longer the chain, the more tightly the two sides of the RNA are going to hold on, even at temperatures that would boil water and destroy RNA. If you can't get them apart without destroying them, it's a dead end.
Number 3, fidelity of template copying. When a molecule is copied, there's a chance for an error to sneak in. Occasionally, this is fine, but too many errors lead to something called an error catastrophe, where the whole sweater comes irreparably unraveled and jumbled. Number 4, rate of template copying. Basically, RNA as a whole has an expiration date, like yogurt. After a short while, they degrade and are no longer RNA. Since there's this timer going, RNAs have to replicate rather swiftly or die. Time is a constant enemy. Number 5, reactivation. Basically the same thing as number 4, but the building blocks themselves also have their own expiration date. Again, time is not friendly to abiogenesis. Number 6, divalent metal ions. These are things that are supposed to help, but they actually degrade the RNA over time and hamper membranes too, especially magnesium. Number 7, primer-independent RNA replication. The mechanism these proto-RNAs needed to replicate required constant access to these primers, but the protocells would prevent this because the building blocks are too big. Number 8, strand re-annealing. In life, there are these enzymes that prevent individual strands of RNA that we want to copy from sticking right back together again, and it also keeps them apart. In proto-life, even if you could get RNAs to separate, they will just join up again before any substantial replication can get started. They have to remain separated if they're going to go on replicating. Spaghetti wants to stick. In number 9, something Szostak didn't mention, but it's an important problem: regulation. If RNA production isn't regulated, it'll lead to something we'll call the spaghetti conundrum. If nucleotides just naturally linked up to replicate RNA, all of a cell's stores of available nucleotides would rapidly be depleted. This would mean any protocell would just be full of a useless jumble of RNA spaghetti. Hang on, these papers show chemical evolution actually happening in the lab. They've literally shown changes in replicating RNAs over a number of generations that lead to better RNAs. So what about that? What they actually do is involve various forms of cheating to claim self-replication. These papers stole a relatively large RNA from existing life, and it already had an unusual ability. It had 4 parts that can come together to form a complete RNA. So they played with these pieces for a bit and rearranged some of them with fun new results. Interesting, but not self-replication or relevant to the origin of life at all. This one steals even more things from life, the entire translation system, hundreds of genes. Basically, they didn't just steal a Xerox machine, they stole the whole supply chain and factory. Okay, but haven't you heard of the RNA peptide world? It's gaining momentum with scientists these days. They say that RNA didn't act alone to start replication. Maybe RNA in these peptides or junior proteins helped each other replicate, like these papers suggest. Sure, peptides do make RNA more stable, increasing its shelf life, so to speak. But on the other hand, it gets in the way when it has to replicate. The RNA peptide world addresses almost none of the 9 problems we just raised with RNA world. They did produce some various peptides, but what they produced conveyed none of the information stored in the RNA, and there's no hint that this system would be capable of self-replication. That's not very promising for a protein manufacturing process. The RNA peptide world is gaining popularity, but notably, this work is an admission that the RNA world hypothesis is not well supported by actual evidence and is in need of serious help. Check out the title of this paper, The RNA World Hypothesis, the Worst Theory on the Early Evolution of Life, except for all the others. Yeah, but hang on. This is just proof of concept, don't you get it? You're being too picky. No, yeah, I get it. If abiogenesis takes place over millions of years, it's unreasonable to make scientists wait that long to replicate it in the lab. We do need to use some shortcuts to make things happen within a reasonable timescale. That's fair enough. However, what's actually done is so far beyond that, and the results, even with this cheating, are so breathtakingly exaggerated that they bear little resemblance to reality. If we steal something from already living organisms in order to prove the concept that life could have started before that thing existed, that's not a proof of concept. That's clearly cheating. But that's just what these experiments do. There's an old story about a professor who was walking home and he fell into a deep pit.
I need to get a ladder to get out of this hole. Luckily, I've got a ladder at home. I'll just go get the ladder, bring it back so I can get out of this hole. A perfect plan!
The truth is, whenever you see a paper or popular article about the origin of life, you can pretty well bet that they're cheating in a number of different ways and that the headlines bear no relationship to reality. Importantly, these aren't problems merely because we don't yet know how these various processes work. The very concept of the self-replicating molecule that chemically evolves into life contradicts many very well understood laws and processes of chemistry, much like perpetual motion contradicts many well understood laws of physics. This isn't an argument from ignorance, but an objection from an abundance of data. When looking closer at the science behind the claims of prebiotic self-replication, it always involves human intelligence, scientists selecting, directing, and crucially, stealing components from already existing life. None of this work is proof of concept for the origin of life, no matter how loudly or frequently they claim it. Did you know that all penguins are left-handed? Bet you didn't know that, because that's not true. I made it up. Well, it might be true, but still, I did make it up. It's easy to say things that aren't true and get people to believe them, especially when they sound sciencey and are mixed in with well-known facts. On that note, let's take a look at some popular science videos on the origin of life and point out a few things they claim that are not exactly true. Let's get into it. The first sort of made-up thing you should be on the lookout for is what we call imagination storytime land. Let's start with these videos from Be Smart and Stated Clearly. When discussing the origin of life, they use words like,
"These molecules must have copied and made more of themselves, some a little different than the others. And a few of those codes and instructions must have been better at doing whatever they did."
it must have happened.
These building blocks combine to form highly complex and orderly structures like genes, proteins, and cell membranes.
Easy as that, they just combine.
Unfortunately, the RNA-only world went extinct more than 3 billion years ago.
See how they slipped into the past tense as if these things are proven? Notice there were not a whole lot of sources cited or evidence given, just imagination and hopeful possibility. If you see words like, "this must have happened," or people casually slipping into the passive voice or past tense, you can be pretty confident that it's story time. People only say something must have happened if they're really not sure that it happened, but want to act like they're sure that it did happen. If I went to the store yesterday, I wouldn't say, I must have went to the store. I'd say, I went to the store. Now, we're not criticizing them for having ideas about what may have happened. Having a hypothesis is fine. Great, even. If it's openly disclosed and everybody's on the same page, nothing wrong with that. But it's frequently presented so matter-of-factly and interspersed with real scientific facts that it's easy for people to mistake it for fact when it's far from the case. They're overcompensating. It's a false confidence. Alright, you know how to spot story time. Cool. The next place we'll go on our tour of science videos is Half-Truth-a-Land. Technically true, but also misleading. Like this.
Hey, hon! Have you seen my cookies?
No. I don't currently see them. Technically true, A lot of times, what is said is technically true, but critical information is left out to intentionally or unintentionally mislead people.
Miller's experiment took some simple chemicals like those found on early Earth.
Did you catch it?
Like those found on early Earth.
They used simple chemicals like those found on early Earth. He knows that they didn't use chemicals actually thought to be on a prebiotic Earth, but they were like them. Chemicals are chemicals after all, right? Not only that, but they used ultra-pure chemicals at extremely high concentrations that are not found in nature and purchased them from industrial laboratory supply shops. Where are you going to find those on a prebiotic Earth? You won't, that's where.
Like those found on early Earth, bubbled them up through a tube, zapped them with electricity, and after a few days, floating in this soup, he found amino acids, the building blocks of proteins and one of the essential ingredients for life.
That's true, but the rest of the story is that they mostly ended up with garbage. Any trace amounts of useful material would have been lost in a sea of toxic byproducts and tar.
Researchers have recently discovered that many of the building blocks of life, amino acids and sugars, exist inside of meteorites.
It's well known that space is full of the chemical building blocks of life, from amino acids to DNA and RNA letters, buried inside meteorites like this one that fell on Australia in 1969.
This tells us that these special molecules are being produced spontaneously all throughout our solar system and may have been common on the ancient Earth.
It shows the chemistry that makes biological molecules can happen pretty much anywhere.
The half of the story that's true is that we have found some building blocks in meteorites. The other half of the story they don't disclose is that, much like the Miller-Urey experiment, these building blocks and letters are utterly unusable because they're mixed in with millions of other molecules that we don't want and are even toxic to life. You could probably find some undigested molecules of flour and sugar inside of a fresh dog poo, but that doesn't mean you're on your way to making a birthday cake. Well, unless you don't like the person. Cakes need lots of pure, uncontaminated ingredients. So does life. Bringing up these meteorites is half true and very misleading.
What made Miller's experiment so special was it gave us proof. Regular non-life stuff could become cool life stuff super easily.
Super easily.
If you understood him to mean that non-living things can easily be turned into living things and that abiogenesis is super easy, you could be forgiven for misunderstanding this misleading half-truth. What was actually meant is that chemicals, non-living stuff, purchased from industrial chemical supply shops, can be turned into different non-living stuff under circumstances that are completely irrelevant to the origin of life super easily. But put that way, the argument seems much less convincing though. Half-truths are one thing, but let's go deeper now, beyond half-truth-land. In order to find claims that are so exaggerated, so far removed from reality, we need to venture into outright falsehood jungle.
Scientists have constructed ribozymes that can copy themselves, just like DNA gets copied.
No reference is provided because this flat out isn't true. There have been lots of experiments that make misleading claims, but actually reading the papers shows that they steal things from life and don't actually end up with anything self-replicating. If you're okay with that definition of self-replication, I'd like to sell you some self-baking cupcakes. Oh, how lovely.
Just add cupcake mix and bake at 350 for 15 What? Or steal cupcakes from someone who already has them. This isn't self-baking at all.
This is what they're selling you. Having completely misrepresented the possibility of RNA self-replication, this stated clearly video goes on to make false claims about cell membranes and DNA replication.
Some self-assemble into hollow spheres, almost identical to the membranes of modern living cells.
This is outright false. The description is not even close, certainly not almost identical. See this video if you want to see the required capabilities of cell membranes. Saying these hollow spheres are almost identical to real cell membranes is like saying a dinosaur-shaped chicken nugget is almost identical to a real T-Rex, or a cup with a string on it is almost identical to a smartphone. A paper airplane is almost identical to a commercial aircraft. You get the point.
Others self-assemble into long columns, remarkably similar to the strands of DNA found in life.
Anyone with even a basic understanding of DNA should be scratching their head at this claim, pondering how these stacks of disks could possibly be remarkably similar to DNA. This has no resemblance to the structure of DNA, how it's produced or replicated, or how it stores information. As a side note, there aren't any references in the original video by Stated Clearly, but these images look like the work of Otto and team. They found that these disk molecules stack up spontaneously, and if a stack is stirred or shaken to break it into two smaller stacks, each will continue to grow. From this, they claim self-replication, but there's no replication of information and no resemblance to what DNA is or how it functions in life at all. This last one is a doozy.
Researchers have found that with a little bit of assistance, base pairing allows chains of RNA to replicate and evolve. Here's how it works. When a long chain of RNA is suspended in cool water with high concentrations of free nucleotides, the chain can act as a template for its own replication. Nucleotides automatically base pair with their partners on the existing chain. If their backbone atoms form chemical bonds with each other, and by the way, this is the part that currently requires assistance from researchers, we're not yet sure how this would have happened in the wild, a complementary RNA strand is born, one with the exact inverse sequence of the original. If the water is then heated, paired bases lose their grip, allowing both chains to act as templates when the cycle repeats.
The only thing wrong with this claim is pretty much everything about it contradicts well-established science. Here's just 5 reasons why. It starts with this beautiful RNA molecule that needs to be duplicated. This can't happen prebiotically. Notice that the template RNA is unfolded. RNA like this has no function. If it remains unfolded, it can't do anything and will never be selected for because replicating it doesn't grant any benefit, because it doesn't do anything. But if it was folded, it couldn't be duplicated. And the colder the water is, the more likely that it'd be folded up on itself as well. This handsome RNA also isn't bonded with anything else. Unlikely, especially considering that it could bond with itself and the overwhelming amounts of garbage floating around in nature, other interfering molecules and ions getting in the way. But water would also prevent the bonds we want, because hydrogen bonds between a nucleotide and the water itself are stronger than they are between individual nucleotides. In other words, these molecules are not single and ready to mingle. They've already got a honey. They also show free nucleotides in high concentration floating in water. Where do you even get high concentrations of free nucleotides on a prebiotic Earth? The same place you'd find high concentrations of free $100 bills. Only in your dreams. It's not degraded. Again, unlikely considering that its lifespan is similar to that of cottage cheese, especially since the water it'd be floating in would degrade the RNA and the individual nucleotides. This is why in laboratory synthesis, storage, and use of DNA monomers actually occurs in the absence of water. Not to mention ions that would damage the RNA, especially divalent cations like magnesium that cause RNA to cut itself into tiny pieces. Also, any increase in pH would destroy the RNA. Even if the template and complementary strand could form, they can't. Once they got to be longer than about 20 or 30 nucleotides, they'd permanently become a dead end, because not even boiling water could separate them without destroying them completely. So when this video says,
"Here's how it works,"
you should translate it in your head to be, "Here's how it doesn't work, but we need it to work this way for our hypothesis to have any hope, so please be nice." But if the evidence isn't really there like they say, why do such smart people cling to a poorly supported, scientifically dubious belief? A big reason is something called
methodological naturalism.
This is a hidden philosophical starting point that ultimately assumes only one possible explanation: natural causes, no matter how remote or impossible the odds, and ignores all others, no matter how face-slappingly obvious. Methodological naturalism is how these videos can claim that the evidence we see
all makes sense only if
their theories of abiogenesis are true, and this idea that
the most promising idea right now is that life emerged from chemistry.
Because they've excluded all others, so it's the only possible idea. This is like winning first place in a race when you're the only one in it. After you exclude all possible alternatives, we shouldn't be surprised that the remaining idea becomes the most promising idea, even if it's false. The question being asked in Origin of Life science is, how did natural processes begin life? Instead of the more open and honest question, How did life begin? If we were investigating a death, the best thing to do would be to come at it with an open mind. Maybe it was natural causes, maybe not. Either way, we'll collect all the evidence before drawing a conclusion. Perhaps the deceased was quite elderly, alone in the house with all the doors locked, and he was found peacefully lying in bed. Natural causes would be a pretty compelling case. On the other hand, if we found a young healthy person with signs of a struggle, the house was broken into, multiple bite wounds in the back, someone did this would clearly be the better fit to explain the evidence we saw. If the forensic scientists did what origin of life scientists do, they would misdiagnose the cause of death. They'd not only be wrong, but embarrassingly and confidently so. Sure, they could try to explain away all the evidence they found to fit their preferred conclusion. Maybe they just don't want to live in a world where people are murdered. So all evidence of murder is ignored or explained away.
Nah, this house wasn't broken into. That rock that broke the glass in the door is a naturally geologically formed object, easily explained away by physics. And about the house being trashed, maybe a strong wind just blew through and messed up the place. Or an earthquake. Plenty of hypotheses that could explain that as well. No problem. Now, the odd-shaped wounds in the back, I'll admit, hard to explain, but that doesn't mean it was a murder. This was clearly a death due to natural causes. Forensic science, it just needs to advance a bit further, and eventually we'll find a way to explain away this evidence.
Obviously, that detective would be fired, rightfully so. But not so in the origin of life science. He'd be given tenure, a big funding grant, and invited to do a TED Talk. Hey doc, I think I've got an ear infection. Antibiotics are a wonderful medicine when dealing with bacterial infections, but unfortunately they're sometimes misused.
My car is making this funny sound. Chooka 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 chooka.
When antibiotics are misused, it can lead to them suddenly not working anymore. And if you ask folks like Richard Dawkins and Bill Nye the Science Guy, the answer is that this is incontrovertible proof of evolution right before our very eyes. It's an evolutionary arms race, they say. As our weapons of medical warfare get stronger and more sophisticated, so too the bugs we're fighting are getting stronger. They're evolving better defenses, making them immune to the best we can throw at them. The power of natural selection and random mutation laughs at our incompetent medical prowess. Bacterial evolution and antibiotic resistance is one of the all-time greatest hits regarding evidence for evolution. And it's true that antibiotics do sometimes stop working. And antibiotic resistance is a form of evolution, narrowly speaking. But is this a demonstration of the creative power of Darwinian evolution, or is there something else going on? Let's take a look more closely. Let's get to know these bacteria killers we affectionately call antibiotics. How do they keep us alive? Where do they come from? What's their favorite kind of ice cream? There's a lot of ways for antibiotics to defeat bacteria. Some explode it. Some gum up the works. Some starve the little bugs out. Others prevent them from multiplying, and so on. But there's essentially only one or two ways that bacteria can become resistant to antibiotics. The first and most common way bacteria gain resistance is that it's always been there. Antibiotic-resistant bacteria actually pre-exist the invention of modern antibiotics. There's an interesting story of some Arctic explorers from back in the 1800s. Turns out they froze to death before the discovery and use of antibiotics. Some morbid scientists found them recently and took samples of their gut bacteria and found that they already had resistance to some of our most powerful modern antibiotics. Just like some people are naturally short and immune to limbo bars, some bacteria naturally have a pre-existing resistance to antibiotics. Not because they've gained this ability after an encounter with the antibiotic, but it's just always been the case. That said, bacteria do have a neat special ability that short people don't have. They love to share. Not just cooking recipes and financial advice, but super personal things like their very own DNA. They'll swap loops of DNA called plasmids in a process called horizontal gene transfer, or HGT. Like third graders with Pokemon cards, they have no idea how they got them or even what they do, but they'll trade them back and forth, and occasionally, they'll share these resistance genes. Nothing new has been made or evolved though. Bacteria already had the ability to trade plasmids, and the genes for resistance already existed before antibiotics. This is hardly an arms race, and it's not a demonstration of Darwinian creative power, since there's no new mutations and no new genes that have been made. Not only that, but these extra resistance genes are frequently a net negative on fitness. Bacteria with extra useless genes tend to be less fit than regular old vanilla bugs. Imagine you're in a foot race. You usually don't need a duffel bag filled with camping supplies, a pickaxe, spare bowling balls, and a weed whacker during your typical foot race. If you do, great. Otherwise, it's a huge waste of energy lugging all of that stuff around, and it makes you less competitive. Bacteria with extra genetic load tend to be less fit than regular old vanilla bugs.
What about mutations, though?
This is the second less common, but more interesting way that bacteria develop resistance to antibiotics. How does it work? Scientists are aware of pre-existing resistance. So to exclude it as a possibility in experiments, they can start with a single normal, non-resistant bacteria and let that multiply over and over again, and eventually the bacteria population can still develop resistance on its own. Here's how. When copying their DNA, organisms are pretty accurate and mutations are relatively rare, but given enough time, errors do sneak in, like typos or autocorrect when you're texting someone. Sometimes they're no big deal and you can get along in spite of them. But sometimes these mutations really do something and can confer resistance or even immunity to antibiotics. Amazing, that must demonstrate the mighty power of evolution. Well, hold your horses. It's sort of like someone who has no arms saying that they're immune to handcuffs. No legs? You're immune to toenail fungus. No teeth? Congratulations, you're immune to cavities. Think of how much you'll save on toothpaste and floss expenses. Deaf and blind? You're immune to getting annoying songs stuck in your head. Wow. This poor soul might technically be immune to those things in a perverse way, but it comes at a cost. He's hardly a more fit organism, and these mutated bacteria are just hobbled, busted up versions of the original. Darwinian evolution can't get very far by breaking things. Eventually it'll run out of things to break. And in reality, when antibiotics are removed from the environment, these superbugs just sort of die out, because without the help of the antibiotics keeping the stronger, normal bacteria at bay, they can't compete and they die out. Those are the two ways that bacteria can resist antibiotics. Okay, forget about antibiotics. Let's look at the experiment that Darwinists always point to show evolution right before our very eyes. The granddaddy of bacterial lab work, Richard Lenski's long-term evolution experiment. In this famous experiment, Lenski has simulated in the lab, over the course of a few decades, more than 1 million years of evolution with bacteria. Since humans and other large organisms can take years or even decades to reproduce, it's difficult to see any change between generations happening in our lifetimes. But smaller microorganisms like the bacteria E. coli can reproduce in just minutes, letting us observe tens of thousands of generations and the changes that go along with that in real time. This is what Lenski has done for the past quarter of a century or so. Just let a bunch of E. coli bacteria reproduce and watched what happened. Pretty soon after the experiment began, he noticed that they started to grow much faster than normal. Then, a while later, Lenski's E. coli suddenly gained a new ability to eat something new called citrate. This was an earth-shattering find in the world of evolutionary biology. Scientists were swooning in the streets. To hear them tell the story, this was a huge new evolutionary leap, proving beyond a shadow of a doubt the power of random mutation in natural selection. But would you believe it if I told you there was a problem with this explanation as evidence for the creative power of evolution? No? Good, because that would be untrue. There are at least 3 problems with this explanation. What exactly happened to cause the E. coli to grow so much faster? Well, they broke their flagella. What is that, and why would it make them grow faster? The flagella is a little outboard motor of the bacteria. It helps them move around and do their thing. But Lenski's bugs were in flasks that were swished around constantly, allowing them to get nutrients without ever having to move. They were spoon-fed lazy bums. This usually vital part was not currently needed, so it was a waste of energy, and they got rid of it. It's like selling the wheels off your car when you're at a stoplight. You'll save a lot of gas that way, sure, but you haven't really made a better car, and it'll sort of be a problem the next time you need to go anywhere. Well, what about the citrate thing? It's gotta be obviously true that being able to eat a brand new substance is a good thing for these little fellas. Like if we could eat dirt or something. Imagine the possibilities. Well, to make a long story short, all of the complex genetic pathways and proteins needed to transport and metabolize citrate were there all along. Not only that, but E. coli also already had a sophisticated mechanism to turn this ability on and off depending on its environment, so that they could prioritize their optimum food source, glucose, and not waste energy. All that happened was that the sophisticated control mechanism, this switch, broke. This bacteria lost the ability to turn off an ability that they already had. Now it was stuck always on, wasting energy to try and transport and metabolize citrate even when it wasn't necessary. It's sort of like this alarm clock. It has the ability to make this lovely noise. It's a nice ability, but it can be turned on and off. But what if the alarm clock was broken so that it made that noise forever and could never be turned off? Much better, right? Right? How can this not be a win? Sometimes it's good for your alarm clock to make noise, but it's very good to be able to turn it off too. E. coli could already do a thing, and they were broken so that they did that thing constantly, whether they needed it or not. Maybe you call that evolution, but Darwinian evolution demands innumerable new genes, new proteins, new body plans, new organs, and complex characters that we see in nature. This is not that. It's equivocation, using language so ambiguously that it misleads. For example, Aristotle was Greek. Greek is a delicious kind of food. Aristotle must have been delicious. Evolution has so many definitions that it's sometimes difficult to pin down what is meant by it. One could mean a shift in pre-existing populations, like Darwin's finches or peppered moths, or breeding or cultivation, like dogs or plants. But these are miles apart from extrapolating random mutation and natural selection can build new organs or body plans, or universal common ancestry, zucchini are related to tuna fish, which is even further apart from the wild claim that it all happens strictly through materialistic processes. Darwinists equivocate when evidence is presented to prove one definition of evolution, where there is evidence and everybody agrees, and then another definition is quietly swapped in based on wild extrapolations to hoodwink people who aren't paying close enough attention. To extrapolate from antibiotic resistance to the larger kinds of changes evolution would need to make new animals is kind of like saying, last week, this cow could jump 1 foot high. This week, she can jump 2 feet high. Doubling at that rate in just 30 more weeks, she'll be able to jump clear over the moon. It's a bad extrapolation. There's a hard limit to how high cows can jump. And there's a hard limit to the time and populations available to evolution, and to the number of features bacteria can break before running out of things to break. Darwin didn't write a book called How Pre-Existing Organisms Break Themselves. He purported to explain how novel species came about from a single common ancestor. And at least as far as this is concerned, it was a failure. Darwin can't get very far by squandering pre-existing genetic information. Darwin's mechanism creates variation largely by throwing genetic information overboard and selecting for damaged or broken genes, blissfully unaware that it's marooning itself on an island of genetic fragility, making organisms, ironically, less able to adapt in the future, thus hindering larger scale changes from accumulating. There's an old joke that perfectly summarizes what's going on. Wow, you're so rich. What's your secret to becoming a millionaire? Oh, it's easy. First start with $1 billion and then light a bunch of it on fire. Bacterial evolution is lauded as a premier example of Darwinism in action, as Dawkins puts it, before our very eyes. And actually, it is. It doesn't demonstrate Darwinism's creative power though. Instead, it's a perfect demonstration of Darwinism's impotence. You know what? I never noticed this, but my pet bat has the same number of fingers as my pet alligator. Isn't that a quinky-dink? One of the main arguments Darwin used for his theory was that of homology, these odd similarities between very different animals. Why would they be so similar unless they were related? And this does make sense. After all, take siblings. They look pretty similar. They're closely related. Then take cousins or third uncles or former roommates. Or that weird guy down the street who's always going on about how he's a real human, but you're pretty sure he's just a stack of goblins in a trench coat. You can't fool me, I'm onto you. Anywho, Darwin wasn't the first one to notice this, but he did harness it as a central proof in the origin of species. It's to this day used as great evidence for evolution, but is it really? Here's the story. Careful observers for a long time have noticed that very different creatures have very similar bits. These sorts of ideas date all the way back to Aristotle. If we fast forward to the 1800s, anatomist Sir Richard Owen coined a term for these observations: homology. Take a look at this guy. He's got an arm that starts with one bone, followed by two bones, and then lots of tiny bones for the wrist and fingers and whatnot. Great for grabbing stuff and high-fiving. Whales and dogs have basically the same structure, but they're not so good at those things. Why in the world would that be the case? Before Darwin, biologists chalked this up to common design. Just like a painter has a particular style and reuses similar colors or themes that he likes across a lot of his work, so the thinking went, similarities in animal design pointed to a common designer. A few years later, along comes Darwin, and he figured that these structural similarities were important evidence for his theory of evolution. So, rather than a common designer, he instead credited common ancestry. But which is the proper explanation for these obvious similarities? Enter biologist Tim Barra. Guys, I've got a really good illustration. It'll totally put this question to bed. If you look at a 1953 Corvette and compare it to the latest model, only the most general resemblances are evident. But if you compare 53 and 54 side by side, and so on, the descent with modification is overwhelmingly obvious. The evidence is so solid and comprehensive that it can't be denied by reasonable people. In using this analogy, Dr. Barra actually demonstrates precisely the opposite of what he intended. Here's why. A succession of even very similar forms doesn't demand common descent. It could, in this case it does, instead point to a common designer. These guys, the engineers at Chevy. Intelligent agents are free to reuse things however they want. Just like I use the same password, FluffyBunny123, for everything I do online. So the question remains open, is homology due to common design or common descent? Because the argument was so central to Darwin's case, his followers eliminated the question by simply redefining the word from simple similarity to meaning similarity due to common ancestry. They baked Darwinism into the definition of the word. Homology now typically means similarity due to common ancestry. It's a clever way to end an argument if you can get away with it, but for anybody paying attention, it's a baldly circular one. Common ancestry because common ancestry.
We gotta flag all the play, circular reasoning, illegal use of logic, 5-yard penalty, repeat the 4th grade.
Oh come on, no serious biologist could possibly make that mistake. Nobody defines homology that way and then uses it as evidence for evolution. Come on, people couldn't possibly be that... No. The circular argumentation is still regularly used in high school, even college-level textbooks, and many a YouTube video. The surprising thing is that many otherwise very smart people didn't realize this. However, more and more people are seeing the problem for what it is. So what are the options in trying to solve this problem and escape the vicious circularity? Seeing their success at redefining homology, some try to redefine circular reasoning too. Alright, let's see here. Whoa, it's not circular reasoning. Let's call it reciprocal illumination. Fancying up a term doesn't really change the argument. Did you order a pizza? I told you I'm making meatloaf. Oh, this isn't pizza, it's an elliptical caloric transmission device. Oh, okay. Gahoo! Wait a second. Other attempts were made to escape the circularity, but they had to give up on homology as evidence. And instead, they looked to other lines of evidence for common ancestry, namely DNA. Eyeballing bones was a bit subjective anyway. It's kind of like trying to guess what someone's thinking by looking at their face. Oh wow, I wonder why he looks so sad. You think somebody died? It's hit or miss. But if you could look deeper by, say, reading his diary, you'd be able to see what's going on with far more precision. Dear diary, today was all-you-can-eat Taco Tuesday and I forgot to wear my stretchy pants. I could only eat 7 tacos, and they forgot to add extra guac. This day couldn't get any worse. This is pretty much exactly what scientists do when sequencing DNA. They're able to move to the more objective realm of cold, hard numbers. If you look at different creatures' DNA, the rule of thumb is the more similar, the more closely related, and vice versa. Biologists expected to see a gradual branching path of DNA mutations from species to species, and they did find some success. Take for instance this little guy. He's a gene called cytochrome C. You can find a version of him in such places as your handsome or beautiful self, chimpanzees, dogs, moths, even yeast. He's one of the most commonly sequenced portions of DNA, so it's a great test case to see if the similarities hold up and point toward common ancestry. So, if we compare your cute little cytochrome C to this ugly, hairy chimpanzee cytochrome C, they look exactly alike. Weird. With dogs, there's about 90% similarity, moths about 2/3 similar, and yeast only about half similarity. Wow, just what we'd expect. These results must be really strong evidence of common ancestry. Whoa, no, who let you in here? Shoo, get out of here! Meet cytochrome B. He's a lot like C, except he likes to throw monkey wrenches into Darwin's expectations. He's just one example of many. If Darwinism is true, we should be able to construct a reasonably consistent family tree pretty much no matter what genes we compare. But that's far from the case. In reality, using genes like cytochrome C as evidence for common ancestry is just a good example of molecular cherry picking. Depending on what genes are used, biologists will come up with wildly different ancestry and contradictory trees of life. Comparing different animals' cytochrome B genes, scientists found cats and whales cavorting in the primate club, kicking poor little cute little tarsiers out into the cold. Frogs and birds and fish carrying on together in their own strange little group, and even sea urchins masquerading as chordates.
It's madness!
Molecular evidence, as it turns out, does very little to support homology. It's basically a big, wet blanket for the hopeful biologists who study the field. So, homology can't be used as evidence for evolution because it assumes the very thing it's trying to prove. And when biologists try to fix it by pointing to DNA or other areas, it only further undermines the case. Now, to be fair, doing away with homology doesn't necessarily disprove Darwinism, but it is illustrative of the kind of lazy thinking that's common among many Darwinists. Bad arguments can simply get passed on uncritically. All homology proves is that scientists are just like everyone else, people, and we can be uncritical of things that we want to believe. But what about all the other lines of evidence? We've got biogeography, embryology, antibiotic resistance, whale evolution, even vestigial organs, for crying out loud. Is this kind of lazy thinking when dealing with evidence for evolution a one-off mistake in biology, or is it more pervasive? Really? Bears can't parallel park. You want to hear something even sillier? Darwin thought that bears could turn into whales. Back in the 1800s, when Darwin first published The Origin of Species, this is exactly what he said. And he was brutally mocked by scientists of his day for thinking something so ridiculous. He even retracted the idea from later editions of his book. But here's the kicker. Scientists of today think essentially the same thing. Stupid Darwin thinks bears could have turned into whales. How ridiculous. Everyone knows these wolf, pig, weasel, hippo things or it turned into whales. My, how the tables have turned. Back in the 80s and the 90s, a series of fossils were found that rocked the evolutionary landscape. Paleontologists thought that they had found a clear transitional series of fossils documenting the evolution of whales. University of Chicago evolutionary biologist Jerry Coyne says in his book Why Evolution is True, whales happen to have an excellent fossil record, courtesy of their aquatic habits and robust, easily fossilized bones. This is one of our best examples of an evolutionary transition. Wow, one of the best. Let's take a look at the story behind whale evolution. Is it a good argument or not? So according to Coyne, whale evolution is such great evidence since we have a chronologically ordered series of fossils, and it goes something like this. The sequence begins with a raccoon-sized animal called Indohyus, living 48 million years ago. 52 million years ago, we see a wolf-sized creature called Pakicetus, which is a bit more whale-like than Indohyus. At 50 million years ago, there's the remarkable Ambulocetus. Rhodocetus, 47 million years ago, is even more aquatic. Finally, at 40 million years ago, we find the fossils of Basilosaurus and Dorodon, before we have our modern whales. Let's take a look a little bit closer at this chronologically ordered series of fossils. If you're paying attention, you might be thinking something fishy is going on here, but no, you'd be wrong. That would not be a bad pun because whales are mammals, not fish. But also, yes, something mammally was going on here. Granting the standard Darwinian dates for these fossils, Indohyus is dated as far younger than his supposed descendants, and he's not the only one, more on that later. This is common practice in evolutionary analysis, to ignore where species actually show up in the fossil record and place them wherever makes Darwinian sense, creating what are called chronological inversions, or ghost lineages. Oh, that's so spooky. The fossil record often reveals fossils out of the order that they're supposed to be in. For just a couple of other examples, let's take a look at bird evolution. It's supposed to go theropod dinosaurs evolving into birds, with the fossil Archaeopteryx being evidence of this as an intermediate fossil. But the problem is he appears long before the dinosaurs he was supposed to have descended from. Evolution also got a big stick in its spokes with this guy, Tiktaalik, a fish-like creature that was for years crowned as the smoking gun transitional fossil of fish starting to go from the sea to the land. Brilliant evidence, just what they expected. Until in 2010, fossil footprints of true tetrapods were found in Poland, long before they were supposed to have evolved. And all of a sudden Tiktaalik was dethroned as a transitional fossil because again, the dates are all out of order. Hey everybody, I'd like you to meet my grandpa. Oh, so cute. Is that his name, or... No, his name is Seymour. He is my grandpa. What? Doesn't make any sense. Back to the chronologically ordered series of fossils, Basilosaurus and Dorodon are considered fully aquatic whales. They're not a transition to anything. Okay, maybe they're just trying to pad their numbers a little bit, big deal. Surely the rest of the fossils are intermediate and transitional, right? Well, that depends on how you define intermediate. In paleontology, intermediate doesn't mean what we think it means. Like my parents are intermediate between me and my Gam Gam and Pop Pop.
Oh, hello, sweetie.
Hi, Gam Gam.
Oh my, how tall you've grown. But you're so skinny. Would you like your Gam Gam to make you a nice pot pie? You know, staying healthy.
By intermediate, paleontologists usually mean a fossil is merely morphologically intermediate. In other words, if a fossil has features of a supposed ancestor and descendant, then it is classified as an intermediate or transitional fossil. But with that definition, I would be a morphological intermediate between this jockey and this professional basketball player. But that doesn't say anything about lineage, whether I'm an ancestor or descendant of either one. We could be completely unrelated, or even chronologically out of order, that wouldn't matter. The very thing they're trying to prove, the ancestral relationship, or how they came about, is pure assumption. This is how they can say there's tons of intermediate fossils and be technically correct, while at the same time skeptics can say, yeah, there aren't really any intermediate fossils, and also be correct. The fossil evidence is so meager that Darwinists, in order to prove evolutionary ancestry, they have to use a slippery definition that no one would accept in other areas of life. But for the sake of argument, let's ignore that problem because there's another one. Is there even enough time for the transition from land to water to hypothetically take place? Again, taking the standard evolutionary numbers for granted, we've got about 8 to 10 million years to go from the land mammal Pakicetus to fully aquatic whales. It sure seems like a whole lot of time. It's almost enough time for me to watch a Lord of the Rings marathon with someone who has a really small bladder. But is it enough time for whales to have evolved? The field of population genetics is devoted to calculating how long something like this would take. In the past, it was assumed that this was relatively simple to do, as easy as falling off a log. But more recently, scientists at Cornell University calculated how long it would take for different organisms to evolve 2 simple, beneficial mutations. For fruit flies with their relatively large population sizes and speedy generation times, it'd only take a few million years for 2 mutations to become fixed. For larger mammals like humans, who have much smaller population sizes and longer generation times, they calculated it would take over 200 million years. Again, that's only for 2 beneficial mutations. Okay, so where would whales and their supposed ancestors fall on that timescale? They're not as quick to reproduce as flies, but quicker than humans. So for 2 simple, beneficial mutations, that's supposed to take roughly 43.3 million years. So the evidence shows, using their own assumptions and calculations, that they don't even have 1/4 of the time needed for even 2 simple mutations. And it takes quite a lot of changes to go from the land to the water, it turns out, including some of these lovely attributes.
Concurrent heat exchange system for intra and dominant testes, small vertebra for vertical swimming action, tail flukes and musculature for efficient powered swimming, blood temperature insulation, modified damage to nurse young underwater, fetus and breathe position for labor underwater, special lung surfactants to be able to take in air after swimming at crushing depths, organs transformative flippers and reduction of bone lengths, reduction of pelvis and sacral vertebra, reorganization, musculature for reproductive organ, modification of the teeth, modification of eye for underwater vision, hydrodynamic properties of the skin, emergent side pressure, mandibular fat pad with complex lipid distribution, reorganization of skull bone musculature, modification of air bones, decoupling of esophagus, trachea, emergence of blood hole musculature and neurological control synthesis, metabolism of isovaleric acid, and more.
So, how many mutations does it take to change a package? Ooh, I know this joke. 3. 1 to hold it and 2 to turn the ladder. How many mutations does it take to change a Pakicetus to a whale? Not where I would have gone with that joke, but what do I know? To put that in context, take giraffes and their derpy little short-necked pals, the okapi. They're quite similar, and a recent paper studied their differences and found surprisingly 70 different genes that likely contributed to the giraffe's appearance. If animals that similar required 70 gene changes for basically just a longer neck and stronger heart, it's a pretty safe bet that animals as different as Pakicetus and whales would require at least as many, and more likely many thousands more. But it gets worse. Recently, a new basilosauride fossil was found in Antarctica that, even using the most generous dates for Darwinists, cuts down the time available for the whale transition to about half of the already not enough time of 8 million years, and could even place fully aquatic whales before Rhodocetus, before Ambulocetus in contemporary with, or even before Pakicetus, destroying the entire fossil timeline. So is a whale transitional fossil series any good? Well, once you take into account the padding of their numbers, the chronological inversions, the ghost lineages, more recent fossil finds that discredit the timeline, and their creative use of definitions for what it even means to be a transitional fossil, the mathematical problems using their own numbers, they're all very clever tricks. But once you see how all of this works, it's quite a bit less impressive. To be fair, scientists aren't doing this maliciously. They really believe that evolution is just obviously true. So they reason, whether we have 8 million years or 4 million years, lots of fossils or no fossils. If evolution is true and we have whales today, then they must have been able to evolve, regardless of any problems that pop up. But if you don't presuppose evolution, if you treat it as a hypothesis rather than an assumption, then problems like these become far more difficult to hand-wave away. So these fossil finds certainly are interesting and worth debating, but there's a lot more to it than the uncritical, glossy, one-sided story being told. If this is one of the best evidences for evolution, what does that mean for their other evidence that's not as good? Here's the 30,000-foot recap. The whale series is claimed to be one of the best lines of evidence for neo-Darwinism. We gave 2 arguments why whale evolution is actually quite weak. Number 1, population genetics calculations say there isn't anywhere near enough time for even minuscule amounts of coordinated mutations to take place, even granting all the time that they claim. It just couldn't have happened that quickly. Weak responses have been made here and there, but they all misunderstand the population genetics calculations. Check out the previous video for more information there. And number 2, a fully aquatic whale fossil was recently found that predates nearly the entire fossil series, leaving even less time than before. I supplied a survey of relevant papers to show that there's a strong consensus dating the fossil. Now we got a response from Jackson Weed that claims I made some mistakes with the dating of the fossil. Let's take a closer look and see if that's really the case, or if Jackson is the one who made the mistakes. And if you like these kinds of videos, make sure you subscribe and ring that bell so you can get notified when a new video is released. Let's get started. In the previous video, I included this chart laying out the dates for the fossil in question, and again, granting for the sake of argument all the methods and all the dates as they stood. I said the date originally reported of 49 million years ago, giving the whale series little to no time to take place. Jackson argues that a much younger date better fits the data, which allows for more time for the series to evolve. First up, we have this Dutton study from 2002. Jackson claims that I should have included both data points as well as the error bars in the graph for both of the shell samples from TELM 5. For the sake of argument, if we wanted to add the error bars, it would look like this. A couple of problems with that, though. He's misread the chart. There are not 2 samples from TELM 5, in fact, as Jackson mistakenly says. Their chart includes a single shell with multiple possible dates, the average of which is 46 million years ago, the same date that I have in the chart originally. There were multiple shells that converged on the same data point for the high end of 55 million years ago, and a single shell with multiple possible ages on the other end. That's why the data was represented the way it was. Jackson just misread the chart. But to avoid squabbling about error bars, we'll simplify it to somewhere between TELMs 2 and 5, where this fossil was actually found. Next up, the Ivany paper from 2008. We literally use the numbers exactly from the Bono paper. It includes why they chose the range over the specific value for TELM 4. Next up, this group of 3 papers from Wren, Hart, Kokoza, and Clark, and Harwood. The Bono paper says that an early Eocene age is supported by all of these, which would look like this. If someone doesn't like this analysis, then the problem is with Bono and colleagues, and not me. This is pretty much exactly what my chart showed. Jackson makes another mistake quite frequently throughout his video by assuming that when Bono et al. Refer to the lower part of the Lamaceta Formation, they're excluding TELM 4 where the fossil was found. But just a few sentences before, they clearly specify that TELM 4 is included in the lower part of the Lamaceta Formation. The dates provided by these papers aren't merely providing an upper bound as he claims, they're specifically used to date the rocks the fossil was found in. This mistake is why his chart is off by so much when compared to the data reported in these papers. Looking at the specific data from Wren and Hart, Jackson says that their samples from section 3A roughly corresponds to Telm 2 and 3B corresponds to Telm 5. Actually, he makes another mistake here. Their 3A indicates samples from both Telms 2 and 5, which is early Eocene, Epresian. Exactly what Buono said and what I had in the chart. Specifically, Wren and Hart indicate the latter 36% or so of the Epresian. In their 3B indicates the higher up strata, Telms 5, 6, and 7, which date to the middle or late Eocene. Jackson is wrongly trying to apply the dates from much younger strata to this fossil. Kokoza and Clark. Jackson notes that this paper's figure 2 measured section represents the basal 168 meters of La Meseta Formation. Assuming they started at the base of Telm 1, that would mean they only sampled Telms 1 and portion of 2. The problem is this study doesn't include any Telm labels. This formation is quite large and different studies begin and end their measurement ranges in various places. So the question is, where does their chart line up? Jackson says way down here, but the stratigraphy doesn't even come close to lining up. The base of Telm 1 is a very simple conglomerate in siltstone composition, no burrows, no slumps, etc. Quite different than what is charted by Kokoza and Clark. A much better fit of the stratigraphic features would be somewhere higher up in Telms 2 through 5, which also happens to be what Buono indicates as the basal portion of the formation. Next up, Jackson says of Biald 2013 that it doesn't directly provide an age of anything. They do though. The Buono paper lists 5 Dinocis species that characterize the lower strata which Biald dates, and Jackson ignores all but the youngest sample, but we'll include them below. We've got 45, 65, 55.5, 58.2, 53.9. Of all of these, I took the most favorable dates for Darwinists of 45 million years ago. Even though multiple other papers have Eniadoxista dictyostela's first occurrence far earlier, specifically 49 million years ago, the exact date originally reported. So much for me skewing the data as early as possible, as he claims. I'm really trying hard to be fair and use the dates as they are, granting as much as I can, even passing over much older dates to provide more favorable results for the Darwinists. Next up, we have the Douglas paper from 2014. This one is a doozy. I was unsure of it before, so I didn't mention anything and used their dates as they stood. However, after looking into it more thoroughly, Douglas seems to be making a pretty big mistake, and then that mistake is repeated by the Buono paper as well as Jackson. The Douglas paper says that their assignment of roughly 45 million years ago is based upon 2 pieces of evidence. The first of which is the first occurrence of Eniadoxista dictyostela, which is dominant in these sediments, has been calibrated to Cron C20R roughly 45 million years ago. Checking on those 2 references, they don't actually say that. Douglas simply misread them. They actually say that this specimen dates to Cron C21, not C20, which means their entire basis for dating this far younger than everyone else is wrong. Buono presumably copies their error without checking, as does Jackson. Even the secondary claim that these date to 49 million years ago or younger is playing fast and loose with the data. The paper they referenced actually says 50 million years ago, and many of the transantarctic flora date as far older. Next we have Brinkhouse 2003, Williams 2004. Jackson again incorrectly states that these papers only set the upper age for Telm 2 and don't include Telm 4 where the fossil was found, and again he's mistaken. Buono cites them as supporting a date near the early middle Eocene boundary, which is what I have in the chart. That's roughly 49 million years ago. Finally, we have Biald, 2011. Jackson says that this isn't directly dating the La Meseta Formation, and that it only places an upper bound on the base of the formation of 49 million years ago. But again, no, he continues to make the mistake of excluding Telms 4 and 5 from the base of the formation. All of these papers include them, and they are part of the basalmost section of the formation. And according to this paper, transantarctic flora occurred around the early middle Eocene boundary, roughly 50 million years ago. Again, which is what I have in my chart. There was one additional relevant paper that Buono cited, Kemp 2014, that I overlooked in the last video. They also say that Telm 4 is roughly 52 to 51 million years ago, far older than what Jackson and Buono would prefer. Again, we've only looked at the papers that Buono cited, and as careful as their work was, they are trying to push the youngest possible date. Are there any other papers that could weigh in on the question of the proper age for this fossil? Yeah, there's lots. Very few paleontological studies accept the younger Middle Eocene age for the La Meseta Formation. The overwhelming majority of evidence from different fields, micropaleontology, mammal biostratigraphy, radiometric dating, paleomagnetic data, marine transgressions, they all converge on the older date. To avoid the accusation of citation bluffing or piling on, I'll just provide 9 recent papers that support the consensus for the date of Telm 4, where this fossil was found. Marenzi 2006, low volustatic low stands, and they pin it at roughly 49.5 million years ago. Regaro and colleagues 2013, they say early Eocene Epresian, 49 to 52 million years ago. Gelfo 2014, mammal biostratigraphy, 52.8 million years ago. Senizo and colleagues 2015, 49 to 52.8 million years ago. Engelbrecht 2017, Telm 4 specifically is 52.5 to 51 million years ago. Gelfo 2017, 52.8 million years ago. That's mammal biostratigraphy. Doug Jove et al. 2017, Epresian 56 and 47.8 million years ago. Larama and colleagues 2018, late Epresian, that's roughly 49 million years ago. And finally from 2020, Davis and colleagues, Telm 4 is 52.8 to 49 million years ago. If we overlay all the dates, we get a very interesting picture. The date that was originally reported and included in my video of 49 million years ago is strongly supported by the preponderance of evidence, and if anything, that date is too generous. And even older data is very well supported. Buono and Jackson try to make the case that the data supports a far younger age way out here. Unfortunately for them, the data in this case isn't cooperating. Again, the story being portrayed is vastly different than the reality of the situation with whale evolution. It might just be time to retire the whale series as evidence for neo-Darwinism. Big thanks again to Jackson Wheat for his time in responding to these videos.